This is Dr. T.V. Ramakrishna, a lecture on GATE 2015 syllabus of Electronics and Communication Engineering. The total syllabus is divided into the 8 sessions. The first session is networks. Under this, networks graphics, matrix associated with graphics, incidence, fundamental cassettes, and fundamental circuit matrices, solution methods, nodal and mesh analysis, network theorems, superposition, Thevenin and Norton's, maximum power transfer, star to delta transformation. Steady state sinusoidal analysis using the phasors, linear constant coefficient differential equations, time domain analysis of simple RLC circuits, solution of network equations using the Laplace transform, frequency domain analysis of RLC circuits, two-port network parameters, driving point and transfer functions, state equations for networks. These are some of the textbooks related to the networks. First book is very important textbook. Second session, electronic devices. Under this, energy bands in silicon, intrinsic and extrinsic silicon, carrier transport in silicon. Under this, diffusion current, drift current, mobility and resistivity, generation and recombination of the carriers. Next one is PN junction diode, GNO diode, tunnel diode, BJT, JFET, MOS capacitor, MOSFET, LED, PIN diode and avalanche photodiode. Basis of laser. Device technology. Under this, integrated circuit fabrication process, oxidation, diffusion, ion implementation, photolithography, N-tub, P-tub and twin tub CMOS process. These are some of the usable textbooks. Next session, analog circuits. Small signal equivalent circuit of diodes, BJTs, MOSFETs and analog CMOS. Simple diode circuits are clipping, clamping, rectifiers. Bias and bias stability of transistor and FET amplifier. Amplifiers are single and multi-stage, differential and operational, feedback and power amplifiers. Frequency response of amplifiers, simple op amplifier circuits, filters, sinusoidal oscillators like criteria for oscillations, single transistor and op amplifier configurations, function generators and wave shaping circuits, triple fly timers, power supplies. These are the some of the usable books. Next session, digital circuits, Boolean algebra, minimization of Boolean functions, logic gates, digital IC families, DTL, TTL, ECL, MOS, CMOS, combinational circuits, arithmetic circuits, code converters, multipliers, decoders, PROM, and PLS, sequential circuits, latches and flip-flops, counters and shift registers, sample and hold circuits, ADC, DSs, semiconductor memories, microprocessor 8085 only with architecture, programming, memory, and input and output interfacing. These are the some of the textbooks. Next session, signals and system. Definition and properties of Laplace transform, continuous time and discrete time Fourier series, continuous time and discrete time Fourier transform, discrete Fourier transforms and fast Fourier transforms, jet transforms, sampling theorem, linear time invariant LTI system, definition and properties, causality, stability, impulse response, convolution, poles and zeros, parallel and cascade structures, frequency response, group delay, phase delay, signal transmission through LDA system. These are the some of the usable textbooks. Next session, control systems. Under this, basic control system components, block diagrammatic description, reduction of block diagrams, open loop and closed loop systems, and stability analysis of these systems, signal flow graphs and their use in determining transfer function of systems, transient and steady state analysis of LTI systems and frequency response, tools and techniques for LTI system analysis, root locus, root Hurwitz criteria, Bode plots, Nyquist plots, control system compensators, elements of lead and lag compensation, elements of PID control, state variable representation, and solution of state equation of LTI control systems. These are the some of the usable textbooks. Next session, communications. Under this, random signals and noise, probability, random variables, probability density function, autocorrelation, power spectral density, analog communication systems, amplitude and angle modulation and demodulation systems. Spectral analysis of these operations, super heterodyne receivers, elements of hardware, realization of analog communication systems, signal to noise ratio calculations for amplitude modulation and frequency modulation for low noise conditions. Fundamentals of information theory and as channel capacity theorem. Digital communication systems. Pulse code modulation, differential pulse code modulation, Digital modulation schemes, amplitude, phase, and frequency shift keying scheme, matched filter receivers, bandwidth consideration, and probability of error calculations for these schemes. Basis of TDMA, FDMA, CDMA, and GSM. These are some of the usable textbooks. Last session, electromagnetics. Under this, elements of vector calculus, divergence and curl, Gauss and Stokes theorem, Maxwell's equations, differential and integral form, wave equations, Poynting vector, plane waves, propagation through the various media, reflection and refraction, phase and grouped velocities, skin depth, transmission lines, Cassius impedance, impedance transformation, Smith charts, impedance matching, S parameters, pulse excitations, waveguides, modes of rectangular waveguides, boundary conditions, cutoff frequencies, dispersion relations, basis of propagation in dielectric waveguide and optical fibers, basis of antennas, dipole antenna, radiation pattern, antenna gain. These are some of the usable books. Thank you.